Hi, my name is Neena and I'm going to be teaching on Snell's law. So in order to understand Snell's law, let's talk a little bit about refraction. Refraction is defined as the fact or phenomenon of light being deflected and passing obliquely through the interface between one medium and another or through a medium of varying density. In more simple terms, refraction could also be defined as the change in direction of light caused by the change in the light speed due to difference in medium or density. So let's look at this example. Here we have the interface, which is the horizontal line that divides the two mediums, and then we are going to draw a line perpendicular to the interface, and we will call this line the normal line. The light ray coming in is going to be called the incident light ray, which will be coming in at some angle, and we will call this angle angle 1, or the angle of incidence. In the vacuum area, light travels the fastest. It goes the speed of light at 3 times 10 to the 8th meters per second. Down here is the medium of glass where light travels slower. So what will happen when the light comes through the vacuum and into the glass? The light ray is going to switch direction or bend a little. It will go down in this direction. The angle it creates relative to the perpendicular is angle 2, or the angle of refraction. Before we move on, let's make sure we understand the concept of refraction by using this example in terms of a car. So as you can see, the car has 4 wheels, and let's say that we are driving on a road and we are about to reach an interface where the road ends and the car will have to travel through mud. On the road, a car has good traction and is able to move efficiently. So what happens when the car hits the mud? Assuming that the car is moving in a straight line at the same speed, we are going to need to ask ourselves which wheel is going to hit the mud first. At some point in time, the car will be in this position. And as you can see, this wheel is the one that will hit the mud first. So we need to ask ourselves what happens when that wheel hits the mud. Well, it'll begin to slow that wheel down. However, the 3 other tires be on the road moving faster than the one in the mud. So the right side of the car will begin to move faster than the left side, causing the car to turn. The car will then turn in this direction. So once it hits the medium, in this case mud, it will then travel in the direction that it is turned, and this is just the same general idea as light being refracted. Now that we understand refraction, let's talk about Snell's law. So with the original drawing, with the mediums of vacuum and glass, we can label this as V1 and this as V2. This just tells us the speed at which light is traveling through a particular medium. In this case, V1 is equal to the speed of light, which is 3 times 10 to the 8th meters per second. So Snell's law just tells us that the ratio between V2 and the sine of the angle of refraction, or angle 2, is going to be equal to the ratio of V1 and the sine of the angle of incidence, or angle 1. So along with this, we also must learn about the index of refraction, which any substance has, whether it be water, air, glass, or a vacuum. It's usually denoted as n, and it is defined as the speed of light in a vacuum divided by the speed of light in that specific medium. So we can rewrite this equation as velocity is equal to the speed of light over index of refraction. We will now take the reciprocal of the ratios, so it will look like this. So here we are just going to substitute c over n for v, and we're going to do that to both sides. And then we will multiply each side by n over n, and then those two will cancel out, and so we're left with n2 sine theta 2 over c is equal to n1 sine theta 1 over c. We can then multiply each side by c, and then the c's will cancel out, leaving us with n2 sine theta 2 is equal to n1 sine theta 1. We can now use this equation to solve for different problems. So in this example, we are going to be using Snell's law to solve for the angle of refraction. And we know this because we are given both the index of refractions for both air and water, and then we are also given the angle of incidence, which is just 35 degrees. So based on what we just learned, we know that Snell's law is n1 sine theta 1 is equal to n2 sine theta 2. And using this equation, we can solve for the angle of refraction, which is this right here. So in this example, we are given both n1 and n2, which are just the index refractions of air and water, and then we're given the angle of incidence, which is 35 degrees up there. So all we have to do is just plug in these numbers and solve for theta 2. So here I've just plugged in the numbers, both indexes of refraction and then the angle of incidence. And so to solve for theta 2, we can just divide by 1.333 on both sides. And then using a calculator, we can solve for this side, and then we'll have sine theta on this side. So using my calculator, I was able to calculate this side, and I got 0.4304. So we are going to use that and put that on this side. So 0.4304 is equal to sine theta 2. And in order to isolate theta 2, we are going to take the inverse sine of both sides. So inverse sine of 0.4304 is equal to theta 2. And based on my calculations using my calculator, I got 25.49, which is roughly 25.5. So theta 2 is equal to 25.5 degrees. And that is this angle right here. So this example is a bit different than the last one because we are going to be solving for the index of refraction of glass. In this case, we are given both the angle of incidence and the angle of refraction, and we are also given the index of refraction of air, which is 1.00029. And so using Snell's law once again, we can solve for N2, which is the index of refraction of glass. So like we did the first time, we're just going to plug in our values. So N1 is equal to 1.00029, and then sine theta 1, which is 56, is equal to N2, which is our unknown, sine theta 24, which is our angle of refraction. And in order to solve for this, we are just going to divide by sine 24 on both sides. So here I just rearranged the equation. These would cancel out, and then we'd have 1.00029 sine of 56 over sine of 24. And I'm just going to plug that into my calculator, and that should give me the answer. So when I plug that into my calculator, I get 2.03, which can be rounded to 2.04. So N2 is equal to 2.04. Thank you guys for your attention. Here was the reference that I based it off of. Thanks.